The installation of retaining screens with metal components near a pool can potentially violate the National Electrical Code, specifically related to requirements for electrical safety around swimming pools. Let's delve into the specific concerns and offer some guidance. According to the 2002 NEC Article 680.26b3, metal equipment, conduit, fittings, and other metal raceways are prohibited from being installed beneath the diving area of any pool. Additionally, 2002 NEC Article 680.26b5 specifies that electrical equipment installed beneath the diving area must be specifically listed for that use and identified as such. In the scenario described, the use of aluminum poles or non-metallic poles with metal strips to attach the screen, all within 5 feet of the pool, raises concerns. The presence of metal poles and metal strips could be interpreted as metal equipment which the code prohibits within the diving area of a pool. These screens do not appear to be specifically listed for pool use. There are potential consequences when the electrical code is violated. Firstly, and most importantly, using metal equipment beneath the diving area creates a safety hazard. The risk of electrical shock or injury from contact with the metal increases. Secondly, failure of the electrical inspection is a likely outcome. Thirdly, fines or penalties from building inspectors are possible. Finally, liability for any accidents or injuries that result from the violation can occur. Here are some recommendations to avoid these issues. Firstly, consult with a licensed electrician who can offer expertise in navigating these codes. Discuss the specific code violations and collaboratively explore alternative methods for securing retaining screens in a way that adheres to the NEC requirements. Secondly, the most straightforward solution is to use non-metallic materials. Opt for non-metallic poles and screens that have been specifically listed for pool use, ensuring they meet the required safety standards. Thirdly, consider moving the screens outside the 5-foot perimeter. Installing retaining screens at least 5 feet away from the edge of the pool effectively avoids the stipulations of the NEC. Fourthly, it's important to document compliance. Keep detailed records of any corrective actions taken to ensure that the installation adheres to the NEC standards and regulations. Let's consider some alternative solutions in addition to what we've already mentioned. Firstly, install non-metallic retaining walls or fences around the pool area. This provides a physical barrier without introducing metallic components near the pool. Secondly, use non-metallic screens that are securely attached to non-metallic poles and anchor plates. This combination completely eliminates any potential electrical hazard associated with metal. Thirdly, consider installing a pool alarm system that meets the requirements of the Florida Building Code. This system can act as an additional safety measure, providing alerts if anyone enters the pool area unexpectedly. Now, let's dive deeper into Article 680.26, which focuses on equipotential bonding. Equipotential bonding is a critical safety measure designed to minimize voltage gradients in and around swimming pools, spas, and hot tubs. The primary goal is to create an electrically safe environment by ensuring that all metallic parts and conductive surfaces are at approximately the same electrical potential. This reduces the risk of electric shock should a fault occur. Article 680.26 of the NEC outlines the specific requirements for equipotential bonding in these areas. These requirements are designed to protect individuals from dangerous electrical currents. Section 680.26 covers the general requirements for equipotential bonding. It mandates that all metal parts associated with the pool be bonded together. This includes metal fittings within or attached to the pool structure, metal parts of the recirculating system, and any metal forming shells or components. Section 680.26b goes into detail about the specific components that need to be bonded. This includes the perimeter surfaces, such as concrete decks or paved areas, within a specified distance of the pool. The intention is to create a continuous bonding grid that encompasses the area surrounding the pool. Section 680.26c addresses the bonding of electrical equipment. It requires that all electrical equipment associated with the pool, such as pumps, filters, and lighting fixtures, be bonded to the equipotential bonding grid. This ensures that any fault currents are safely conducted back to the source, minimizing the risk of electric shock. It's crucial to understand the concept of the common bonding grid, which is a network of interconnected conductors that bonds together all the required metal parts and equipment. This grid provides a low impedance path for fault currents, helping to quickly trip circuit breakers or ground fault circuit interrupters in the event of a fault. The effectiveness of equipotential bonding relies on proper installation and adherence to the NEC guidelines. It's essential to use appropriate bonding connectors and conductors, ensuring that all connections are secure and corrosion resistant. Regular inspections and maintenance are also necessary to verify the integrity of the bonding system. It is also important to discuss ground fault circuit interrupters, or GFCIs, and their role in pool safety. A GFCI is a fast-acting circuit breaker designed to protect people from electrical shock. It works by monitoring the current flowing in a circuit and quickly interrupting the power if it detects any imbalance that could indicate a leakage current. These are commonly used in areas where electrical equipment may come into contact with water, such as bathrooms, kitchens, and, importantly, around swimming pools. GFCIs are designed to trip very quickly, typically within a fraction of a second, when they detect a ground fault. This rapid response can prevent serious injury or even death from electric shock. In the context of pool safety, GFCIs are required for all electrical outlets and equipment within a certain distance of the pool. This includes outlets used for pool pumps, lighting, and other electrical devices. The NEC specifies the exact distances and requirements for GFCI protection around pools. Regular testing of GFCIs is crucial to ensure they are functioning correctly. Most GFCIs have a test button that allows you to simulate a ground fault and verify that the device trips as expected. It's recommended to test GFCIs monthly or according to the manufacturer's instructions. When installing or maintaining electrical equipment around a pool, it's essential to follow all applicable codes and regulations. This includes using properly rated and listed equipment, ensuring proper grounding and bonding, and providing GFCI protection where required. Working with a qualified electrician is always recommended to ensure that all electrical work is performed safely and in compliance with local codes. Understanding the different types of pool grounding and bonding is also helpful. There are several key components and techniques used to ensure electrical safety around swimming pools. These methods are designed to minimize the risk of electric shock by creating a low impedance path for fault currents and ensuring that all metal parts are at the same electrical potential. Let's delve deeper into the different types of pool grounding and bonding. Equipment grounding involves connecting all non-current carrying metal parts of electrical equipment to the grounding system. This provides a path for fault currents to flow back to the source, tripping the circuit breaker and energizing the equipment. The goal is to prevent voltage from building up on metal surfaces, which could pose a shock hazard. Bonding, on the other hand, involves connecting all metal parts and conductive surfaces in and around the pool to create an equipotential plane. This ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock if someone comes into contact with two different metal parts. The common bonding grid is a network of interconnected conductors that connects all the required metal parts and equipment. It serves as the foundation for the entire bonding system, providing a lower impedance path for fault currents. Perimeter bonding involves bonding the perimeter surfaces, such as concrete decks or paved areas, within a specified distance of the pool. This creates a continuous bonding grid that encompasses the area surrounding the pool, further reducing the risk of electric shock. Rebar bonding involves bonding the reinforcing steel rebar in the pool structure to the bonding grid. This helps to ensure that the entire pool structure is at the same electrical potential. Water bonding involves bonding the pool water to the bonding grid. This is typically achieved by installing a metal plate or electrode in the pool water and connecting it to the bonding grid. The purpose of water bonding is to minimize voltage gradients in the water, reducing the risk of electric shock to swimmers. In addition to these specific bonding techniques, it's also important to ensure that all electrical equipment is properly grounded and that GFCIs are installed where required. Proper grounding and bonding are essential for ensuring electrical safety around swimming pools. Regular inspections and maintenance are necessary to verify the integrity of the grounding and bonding system. It's recommended to work with a qualified electrician to ensure that all electrical work is performed safely and in compliance with local codes. When it comes to electrical safety around swimming pools, there are several common mistakes that can lead to dangerous situations. Avoiding these mistakes is crucial for protecting swimmers and preventing electrical accidents. One common mistake is improper grounding. Failing to properly ground electrical equipment, such as pumps and filters, can create a shock hazard. It's essential to ensure that all non-current carrying metal parts are connected to the grounding system. Another common mistake is inadequate bonding. Not bonding all metal parts and conductive surfaces in and around the pool can create voltage differences, increasing the risk of electric shock. It's important to bond all metal parts, including the pool structure, perimeter surfaces, and electrical equipment. Another mistake is using damaged or deteriorated electrical equipment. Using equipment with frayed cords, cracked housings, or other signs of damage can be extremely dangerous. It's essential to replace any damaged equipment immediately. Overloading circuits can also pose a serious risk. Plugging too many electrical devices into a single circuit can cause the circuit to overheat and potentially start a fire. It's important to ensure that circuits are not overloaded and that extension cords are used properly. Ignoring GFCI requirements is another common mistake. Failing to install GFCIs where required can leave swimmers vulnerable to electric shock. GFCIs are required for all electrical outlets and equipment within a certain distance of the pool. Another mistake is improper wiring. Incorrectly wired circuits can create a variety of electrical hazards. It's essential to ensure that all wiring is performed by a qualified electrician and that it complies with local codes. Another mistake is failing to test GFCIs regularly. GFCIs should be tested monthly to ensure that they are functioning properly. Neglecting maintenance can also lead to electrical problems. Failing to maintain electrical equipment, such as cleaning debris from pumps and filters, can cause the equipment to overheat and potentially fail. Another mistake is unqualified electrical work. Attempting to perform electrical work without the proper training and qualifications can be extremely dangerous. It's always recommended to hire a qualified electrician for any electrical work around a swimming pool. Avoiding these common mistakes is essential for ensuring electrical safety around swimming pools. Regular inspections, proper maintenance, and qualified electrical work are all crucial for preventing electrical accidents. The specific Florida Building Code requirement related to pool alarms. According to the Florida Building Code, pool alarms are required for new residential swimming pools. The purpose of these alarms is to provide an audible warning when someone enters the pool area, helping to prevent drowning accidents. There are several types of pool alarms that meet the requirements of the Florida Building Code. These include surface wave detection alarms, subsurface disturbance alarms, and gate alarms. Surface wave detection alarms detect disturbances on the surface of the water, such as those caused by someone falling into the pool. Subsurface disturbance alarms detect disturbances beneath the surface of the water, such as those caused by a swimmer. Gate alarms are installed on pool gates and sound an alarm when the gate is opened. The Florida Building Code specifies the performance requirements for pool alarms. These requirements include the sound level of the alarm, the response time of the alarm, and the ability of the alarm to distinguish between normal pool activity and potential drowning event. The Florida Building Code also requires that pool alarms be properly installed and maintained. This includes ensuring that the alarm is properly positioned, that the batteries are fresh, and that the alarm is tested regularly. In addition to the Florida Building Code requirements, there may be local ordinances that further regulate pool alarms. It's important to check with your local government to ensure that you are in compliance with all applicable regulations. Pool alarms are an important safety device that can help prevent drowning accidents. By understanding the requirements of the Florida Building Code and properly installing and maintaining a pool alarm, you can help protect swimmers and ensure a safe pool environment. Let's delve into the specific NEC requirements for underwater lighting, as it's an important aspect of pool safety. Underwater lighting can enhance the aesthetic appeal of a swimming pool, but it also poses potential electrical hazards. The NEC has specific requirements to minimize these risks and ensure the safety of swimmers. According to the NEC, all underwater lighting fixtures must be listed for that purpose. This means that the fixtures have been tested and certified by a recognized testing laboratory to meet specific safety standards. The NEC also requires that underwater lighting fixtures be installed at a minimum depth below the water surface. This depth varies depending on the type of fixture and the voltage of the circuit. The purpose of this requirement is to reduce the risk of electric shock to swimmers. The NEC also specifies the type of wiring that can be used for underwater lighting circuits. Only listed and approved wiring methods are allowed. This includes specific types of cable and conduit that are designed to withstand the harsh conditions of a pool environment. The NEC requires that all underwater lighting circuits be protected by GFCI. This provides an additional layer of protection against electric shock. The GFCI will quickly trip the circuit if it detects any leakage current, preventing a potentially dangerous situation. The NEC also addresses the bonding of underwater lighting fixtures. All metal parts of the fixture must be bonded to the pool's bonding grid. This ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. The NEC also includes requirements for the location of junction boxes and transformers associated with underwater lighting circuits. These components must be located in a safe and accessible location, away from the pool water. The NEC also specifies the maximum voltage allowed for underwater lighting circuits. This voltage is typically limited to 12 volts alternating current or 30 volts direct current. The lower voltage reduces the risk of electric shock. In addition to these specific requirements for underwater lighting, the NEC also includes general requirements for electrical safety around swimming pools. These requirements cover grounding, bonding, GFCI protection, and the use of listed and approved equipment. Understanding and complying with the NEC requirements for underwater lighting is essential for ensuring the safety of swimmers. Regular inspections and maintenance are also necessary to verify the integrity of the electrical system. It is recommended to work with a qualified electrician to ensure that all electrical work is performed safely and in compliance with local codes. Let's explore the electrical inspection process for swimming pools. The electrical inspection process is a crucial step in ensuring the safety of swimming pools. It involves a thorough examination of the electrical system to verify that it complies with the NEC and other applicable codes. The purpose of the inspection is to identify any potential electrical hazards and ensure that the pool is safe for swimmers. The electrical inspection typically begins with a review of the electrical plans and specifications. The inspector will check to see that the plans comply with the NEC and other applicable codes. The inspector will then conduct a visual inspection of the electrical system. This includes checking the grounding, bonding, GFCI protection, wiring methods, and equipment installations. The inspector will also verify that all electrical equipment is listed and approved for use in a pool environment. The inspector may also perform tests to verify the proper functioning of the electrical system. This includes testing the GFCI protection, measuring the voltage and current, and checking the grounding and bonding connections. If the inspector finds any violations of the NEC or other applicable codes, they will issue a notice of violation. The notice will specify the violations and provide a deadline for correcting them. Once the violations have been corrected, the inspector will conduct a follow-up inspection to verify that the corrections have been made. If the corrections are satisfactory, the inspector will issue a certificate of compliance. The electrical inspection process is essential for ensuring the safety of swimming pools. It helps to identify and correct potential electrical hazards, protecting swimmers from electric shock. It is important to work with a qualified electrician to ensure that all electrical work is performed safely and in compliance with local codes. Regular inspections and maintenance are also necessary to verify the integrity of the electrical system.